The year is 1958. 1 year ago, the Soviet Union launched the world's first satellite, Sputnik 1, into a stable orbit in outer space around the Earth. Sorry about that, something caught in my throat. The year is 1958. 1 year ago, the Soviet Union launched the world's first satellite, Sputnik 1, into a stable orbit in space around the Earth. The nuclear arms race between the Soviets and the Americans has quickly evolved into a missile race. Lacking the superior nuclear bomber capabilities of their competitors, the Soviets have moved their focus to ICBMs, long-range ballistic missiles that can reach their targets from thousands of miles away. Development of this technology, in turn, led to the use of orbital rockets for satellites that could perform communications and intelligence work. Following the Soviets' launch of a dog into orbit aboard Sputnik 2, it became clear to the Americans that the Soviets' goal was human spaceflight. In true American fashion, they needed to develop some competition to this. While spaceflight had previously been done under the guidance of the US Army, it was decided that NACA, the National Advisory Council of Aeronautics, would be replaced with a new civilian space program. NACA Director Hugh Dryden stated, quote, "It is of great urgency and importance to our country, both from consideration of our prestige as a nation as well as military necessity, that this challenge be met by an energetic program of research and development for the conquest of space. It is accordingly proposed that the scientific research be the responsibility of a national civilian agency." On July 29, 1958, Eisenhower would sign the documents that birthed the agency we know today, the National Aeronautics and Space Administration. NASA began operations on October 1, 1958, with work already on the table. They absorbed the resources of NACA in its entirety, including their 3 major research laboratories, 2 small test facilities, its 8,000 employees, and its $100 million annual budget. Some elements of the Army Ballistic Missile Agency and the United States Naval Research Laboratory were also absorbed, and the agency was born with an active project that was already in the books. They had inherited the X-15 program from NACA, an experimental hypersonic rocket-powered aircraft that would go on to break world speed records as well as, technically, become the first spaceplane. Its highest flight reached an altitude of 107 kilometers, 7 kilometers above the arbitrary boundary where space begins. However, NASA had other plans that they began to get to work on quickly. Hugh Dryden, now a deputy for NASA's first administrator Keith Glennon, established the Space Task Group just 1 month into the agency's operations in November of 1958. A group of originally 45 engineers, secretaries, and computers, which was the term given to women tasked with performing calculations, the Space Task Group was put in charge of managing human spaceflight programs. Working quickly under the stress of the Cold War and the progress of the Soviet space program, the Space Task Group outlined the goals, requirements, and restrictions of their first program, officially put forth as Project Mercury. Originally named Project Astronaut, President Eisenhower felt this brought too much attention specifically to the pilot. Mercury was chosen instead from classical mythology, as this was already a trend for space rockets such as Atlas and Jupiter. The goals were as follows: place a crewed spacecraft around the Earth, investigate the pilot's ability to function in space, and recover the spacecraft and its crew safely. A set of existing rockets would be utilized as a launch vehicle for the spacecraft, which would be put together through a series of progressive tests. The requirements of Project Mercury added several more layers of challenges. Due to the rockets of the era being very unreliable, a launch escape system would be required, which would separate the spacecraft and its crew from the launch vehicle in the case of an impending failure. The Mercury launch escape system was developed by Grand Central Rocket Company, which later became the Lockheed Propulsion Company, and was a tall tower with a small solid rocket motor at the top. When the launch system detected an anomaly, the rocket would fire and the spacecraft would be pulled away from the failing rocket. Similar launch escape systems would continue to be used throughout history, and even to this day, despite the increasing reliability of the launch vehicles. Further requirements included an attitude control system so that the spacecraft could be reoriented, utilizing a series of monopropellant jets around the spacecraft's exterior that would fire to move it in the desired direction. A retro-rocket system would also be required, something that could fire in the opposite direction of the spacecraft's movement in order to slow it down and deorbit it. Finally, the craft would need a blunt body to be used for atmospheric re-entry. In order to return from orbit, a spacecraft needs to slow down and in a hurry. The best way to do this, it was found, was to use a craft that presented a large surface area for the incoming air to push against, which would in turn slow the spacecraft. 12 companies bid to build the Mercury spacecraft on a, at the time, $20 million contract. In January of 1959, the McDonnell Aircraft Corporation was chosen as the primary contractor, and North American Aviation was awarded with a contract to develop a small test rocket that would be used to develop the launch escape system. A number of different test sites were selected for launches. Crewed launches would be performed at the Atlantic Missile Range at Cape Canaveral Air Force Station in Florida, while smaller test launches would be done at Wallops Island in Virginia. Construction and improvement of a worldwide communications network using 16 tracking stations began in order to stay in contact with the spacecraft while it circled the planet. Resources from around the country and from every branch of the U.S. military were brought together to make Project Mercury operational, and entire towns near the test sites would begin to boom from an influx of jobs and tourism. The principal designer of the spacecraft was Maxime Fazet, who had started his work with the U.S. government during the time of NACA. He was the person to come up with the blunt body shape for atmospheric reentry, and would use this concept to come up with the general cone shape of the Mercury spacecraft. It was 10.8 feet tall and 6 feet wide, with 100 cubic feet of habitable volume, just large enough for a singular human occupant. Its exterior was made of a nickel alloy designed to withstand high temperatures, and inside were 120 controls, which consisted of 55 electrical switches, 30 fuses, and 35 mechanical levers. Its cone shape ended in a narrow neck which contained the recovery compartment, as well as the communications equipment, which would be jettisoned when the parachutes were deployed. At the bottom of the cone, a convex base carried the ablative heat shield. This was made up of an aluminum honeycomb covered with multiple layers of fiberglass, designed to absorb the heat of reentry while the outer surface chars and melts. At the same time, it lifts the hot shock layer gas away from the heat shield's outer wall and creates a cooler boundary layer for the spacecraft to pass through, minimizing damage to it. Below the heat shield were a pack of 2 sets of rockets that would be used first to separate the craft from its launch vehicle using posigrade rockets, and then fire a deorbit burn with retro rockets. This pack would then be jettisoned, exposing the heat shield to the elements it was designed to endure. Between the heat shield and the inner wall of the capsule was a landing skirt, which would be deployed before landing, softening the blow of the splashdown. Inside, the astronaut would be strapped to a form-fitting seat with the instruments in front of him, oriented with his back facing the base of the vehicle, meant to reduce the effects of G-forces during re-entry. Beneath the seat was the environmental control system, which supplied oxygen, heat, CO2 scrubbing, and collected the astronaut's urine on longer orbital flights. Near the astronaut's left hand was a manual abort handle, which would activate the launch escape system in the event that it failed to trigger automatically. The astronauts also wore a pressure suit with their own oxygen supply. The cabin had a pure oxygen environment that was chosen to save on spacecraft weight, as well as avoid the risk of decompression sickness. In the event of a fire, the cabin could be vented of all oxygen, and the astronaut could make an emergency return by relying on the oxygen in his pressure suit. He would also wear a number of instruments designed to monitor his health, which was another key element of the Mercury program. A number of decisions in designing the Mercury spacecraft were heavily influenced by the astronauts themselves. They took part in the development process, helping engineers to figure out the ideal placement of equipment and controls so that the astronauts could easily reach and work them. Their suits could be inflated or deflated, and they would usually fly deflated, but if they needed to be inflated, the astronauts would still need to be able to reach the most critical controls, such as the manual abort handle. The fact that the manual control system even existed was an astronaut decision, insisting that it was necessary for a pilot to be able to take control in the place of a communications failure. As the spacecraft had no onboard computer, all automatic controls were made by commands sent from the ground, and the astronauts didn't believe this could be solely relied upon. In order to complement the manual controls, they also insisted that the craft feature a window for orientation purposes. They were also able to look at a screen connected to a periscope that had a camera and could be turned 360 degrees around.
The astronauts have made a great many contributions to improve the effectiveness of Project Mercury. They work closely with the engineers. Each man is assigned to a particular phase of the program, such as communications, tracking, or the launch vehicle. He keeps his fellow astronauts informed on any changes or modifications.
The Mercury spacecraft design was modified 3 times by NASA between 1958 and 1959. Having initially selected the C design in November of 1958, a final configuration, D, was established after the C design failed a test flight in July of 1959. During the development of these various designs, work was being put into designing the heat shield. Experiments with ballistic missiles had shown that a blunt profile would create a shockwave that would send the majority of heat around the spacecraft, but one question remained as to how the shield itself would function. The first option was a heat sink, which utilizes a fluid medium such as air or liquid coolant to dissipate heat away from a device. A good example is the large piece of metal and fan that sit on top of your computer's central processing unit. The CPU generates a large amount of heat, which then passes into the metal heatsink and is expelled out by the fan. However, the choice was made instead to make the Mercury heat shield out of an ablative material, due to wind tunnel tests showing the difficulty of designing an aerodynamically sound heat sink. When design work began on the Mercury spacecraft, so did the astronaut selection and training process. Prior to this, there had been no protocol for selecting astronauts, and Project Mercury would set the precedent. After closed-door discussions within the national government and open-door discussions with the public at large, the decision was made that NASA's first astronauts should all be qualified test pilots. Initially, there was an idea to make a widespread call for volunteers, bringing in thrill seekers such as rock climbers and acrobats. However, the idea was quickly shot down by NASA, who insisted that an undertaking such as spaceflight required individuals with professional training and education in flight engineering. By late 1958, coordination with President Eisenhower had narrowed the number of candidates down to 508. They then began to further whittle down this group by comparing their service records and finding the most skilled pilots of the group, stipulating requirements for age and height, and requiring that they hold at least one college degree in a STEM subject. During this time, one particular pilot was disqualified due to having left active military service in 1952. This made him a civilian pilot who is currently conducting test flights for the X-15 program. In 1962, he would become NASA's first civilian astronaut, by the name of Neil Armstrong. A number of other potential candidates ended up declining the proposal, believing that human spaceflight had no future beyond Project Mercury. Then Lieutenant Colonel Chuck Yeager, who was the first person to exceed the speed of sound, was disqualified due to not having a college degree, and Yeager would later become a vocal critic of Project Mercury, ridiculing the space program and labeling astronauts as spam in a can. Of the original group of 508, 110 candidates were selected for interviews. Of these 110, 32 were selected for further physical and mental testing. Their health, vision, hearing, as well as toleration to noise, vibrations, g-forces, personal isolation, and heat were all put to the test. They were placed in a special chamber and asked to perform tasks under conditions designed to make them feel confused and disoriented. They were made to answer a list of 500 questions about themselves and describe what they saw in different images. At the end of this long and complicated process, NASA had its first group of astronauts, dubbed the Mercury 7. Scott Carpenter, Gordon Cooper, John Glenn, Gus Grissom, Wally Shura, Alan Shepard, and Deke Slayton. As a quick amusing aside, you may notice in this photo of the Mercury 7 that the front and center two astronauts have different boots than the others. This is because the boots for their actual suits weren't finished yet, and were told to simply spray paint their work boots. Scott Carpenter was a naval aviator, having flown a Lockheed P-2 Neptune on reconnaissance and anti-submarine missions along the coasts of the Soviet Union and China during the Korean War and in the Cold War. In 1954, he became a test pilot for the Navy, and in 1958 was named Air Intelligence Officer of the USS Hornet, then in dry dock. The following year, he would join Project Mercury, and afterwards would take a leave of absence to join the Navy Sea Lab project, working with experimental deep-sea habitats. He retired from NASA in 1967, and from the Navy 2 years later. Gordon Cooper learned to fly as a child in his parents' biplane, and got his pilot's license at age 16. He joined the Marine Corps after high school to serve during World War II, but the war was over before he was able to do any overseas service. He then joined the Air Force and served as a fighter pilot between 1949 and 1956, at which point he became a test pilot before being selected for Project Mercury in 1959. Afterwards, Cooper would remain with NASA until 1970, having served in the subsequent Project Gemini, as well as being a backup pilot for Apollo 10. When he retired, he would go on to serve on several corporate boards as a consultant for fields ranging from high-performance boat design to construction and aircraft design. John Glenn was a distinguished World War II fighter pilot, as well as serving during the Chinese Civil War and the Korean War, which awarded him 18 different air medals. In 1957, he made the world's first supersonic transcontinental flight across the United States in a Vought F-8 Crusader. He made this flight primarily due to boredom brought on by a desk job at the Navy Bureau of Aeronautics. This job did, however, give him access to spaceflight news, such as the X-15 rocket plane and the still-forming Project Mercury, information he absorbed intensely, becoming extremely interested in everything space-related. Joining Mercury made Glenn a resident expert due to his extensive flight experience, and was one of the most instrumental astronauts in terms of assisting with the Mercury spacecraft design. Glenn retired from NASA in 1964, was elected to Senate, and would later become the oldest person to enter Earth orbit when he flew aboard Space Shuttle Discovery at age 77. He was also the only person to fly in both the Mercury and the Space Shuttle program. Virgil Gus Grissom was also a World War II veteran, as well as serving in the Korean War. He earned his pilot's wings in 1951 and flew 100 combat missions during the latter war. After rotating home, he was assigned to work as a flight instructor for the Air Force, and then later as a test pilot at Wright-Patterson Air Force Base. He was selected for Project Mercury in 1959, and after his flight, would go on to do a second flight for Project Gemini. Sadly, Grissom would perish in the tragic Apollo 1 fire in 1967. Wally Shura, like Grissom, was a veteran of both World War II and the Korean War, having flown 90 missions as a fighter pilot in the latter of the two. His father had been a World War I pilot, and Shura would follow in his footsteps after the attack on Pearl Harbor in 1941 when he enrolled in the United States Naval Academy. He would be sent into the war 4 years later and spend its final months aboard the cruiser USS Alaska. Following Japan's surrender, he returned to the United States and received his naval aviator's wings in 1948. He was deployed on the carrier USS Midway at the outbreak of the Korean War, during which time he would transition from the Navy to the Air Force, flying an F-84 Thunderjet for the rest of his tour. After his time with Project Mercury, Shura also flew on Gemini 6A, performing the first orbital rendezvous, and then command Apollo 7, the first crewed launch of the lunar program. He was the first astronaut to go into space 3 times, and the only astronaut to fly in the Mercury, Gemini, and Apollo programs. Alan Shepard was an exceptionally smart student, and when he graduated school a year early in 1940, he joined the Navy. He passed the entrance exam, but at age 16 was too young to enter, and was instead sent to a naval prep school. He graduated in the class of 1945 and was posted to the destroyer USS Cogswell. The next year, he would commence basic flight training in Texas. He struggled to learn, but took private lessons at a local civilian flight school to help him improve his skills. By 1947, his instructors rated him above average, and his naval aviator wings were pinned on his chest by his own father. By the time he was selected for Project Mercury, he was an instructor at a test pilot school in Rhode Island. After becoming the first American in space, Shepard was slated to be the first commander of a crewed Gemini mission, but was grounded after an inner ear disease diagnosis. He remained chief of the astronaut office for the duration of Project Gemini, and after being given a newly developed treatment for his illness, went on to fly Apollo 14 in 1971. Donald Kent Slayton, better known as Deke Slayton, flew in both the European and Pacific theaters during World War II, with 3 different aircraft. Afterwards, he enrolled at the University of Minnesota, finishing with a Bachelor of Science degree in Aeronautical Engineering. After briefly working for Boeing as an aeronautical engineer, he returned to military service for the Korean War, though saw little combat due to waiting for medical clearance regarding his eyesight. After the war, he went on to be a test pilot at Edwards Air Force Base in California, which led to his selection in Project Mercury, though he would be the only one in the program who never actually flew. Afterwards, he would take part in the iconic handshake between nations, the Apollo-Soyuz project, as well as be a key contributor to the development of the Space Shuttle program. He flew a T-38 chase plane alongside Space Shuttle Columbia during her second landing, and formally left NASA in 1982 with over 7,000 flight hours. They had the crew. They had the spacecraft. The astronauts had worked with the design team in order to optimize everything in preparation for real flight tests. The Mercury 7 went through a number of academic training programs to enhance their comprehension of the math behind the planned flights they were to undertake. They went through physical tests, from zero-G flights to simulations of high G forces and temperatures. The simulators ramped up the difficulty as they went on, preparing the astronauts for every possible scenario, every potential failure, every unlikely eccentricity.
On water impact, the pilot will normally sit back and wait to be picked up by helicopter or ship. However, in an emergency, if the craft is sinking or ventilation fouled, the pilot can climb out through the top. There's always the slight chance the spacecraft may land outside the designated area. The pilot is prepared and equipped to survive while waiting for the recovery teams to reach him. Training covers every conceivable eventuality, every emergency, no matter how unlikely it is to occur.
It was now time to begin real-world testing. First, obviously, would be uncrewed tests of the various systems of the Mercury spacecraft. A small solid-fueled booster called Little Joe was designed to loft the craft into the air in order to perform these tests, and its first flight, dubbed Little Joe 1, was to test the Mercury launch abort system during an ascent. On the 21st of August 1959, Project Mercury began 30 minutes ahead of schedule while the pad was still being evacuated. There was a flash of light and a burst of smoke, and once it had cleared, everyone realized that the spacecraft and abort system were gone. The abort system worked, perhaps better than expected. If you enjoy this content, consider hitting the subscribe button. If you really enjoy this content, consider donating on Patreon, becoming a member, buying some of my books on Amazon, or buying some of my merch. Thank you very much for watching, and I will see you over the curve, Space Cowboys.